So, we learned a long time ago that circumference of a circle is the distance around the outside edge of a circle. It's kind of like a perimeter, but we don't call it perimeter for circles. We call it circumference. That means you're going all the way around something. Do y'all remember the formula for circumference of a circle? Pi times diameter. Or diameter is what? Not half. Twice the radius. So, not pi r squared, it's 2 pi r. 2 times the radius. So, pi times diameter or pi or 2 pi r. Because 2 times r is the same thing as d. Right? Hang on. What's next? Okay? Got it? That's circumference. That's the distance around. All right. So, pi times diameter or 2 pi r is the circumference of a circle. The area, which means how much space the circle takes up, is what? Pi r squared. Which is funny because pi are not square, pi are round. Right? Math teacher jokes, right? Yes. Okay. So area is pi r squared. Circumference is 2 pi r or pi d. Okay? Got it? Memorize those. All right. A sector, we're filling in the blank, of a circle is the region that is bounded by 2 radii. I like that word, radii. Radii of the circle and their intercepted arc. So a sector is like a piece of pie. Okay, if you cut a wedge out of a sector, that would be, or cut a wedge out of a circle, that's called a sector. Did I tell you about Jonah and his cornbread one day? Yes. Jonah likes cornbread, so sometimes I make cornbread just for Jonah. I know, I school my kids. But anyways, so here's our cornbread. Pretend that's a circle. Okay? So I cut him a little wedge out of it, and it's little because he's little. And I don't want crumbs all over my house. So I cut him a piece of cornbread, and he said, "Mommy, that's a triangle." I said, "Well, it's got 3 sides, so that part's correct." I said, "Baby, that's not a triangle, that's a sector." So yes, he was 3 at the time I corrected him and told him that was a sector. So Bobby goes and cuts him a big old wedge out of that cornbread because Bobby likes cornbread too, and I make really good cornbread. Sure, yeah. It's only good hot though, then I can't make it so big hot. All right, so Davis, my oldest, said, "Daddy, you got you a triangle." Jonah said, "It's a sector." So yes. Weird math teachers teach their kids correct mathematical terminology. So y'all, when y'all eat your pizza next Friday, it's not going to be. When you eat your pizza, those are sectors. So technically pizza is related to circles in math class. Okay? Yes. Well, I think it's going to be that he says that you might get it to where everybody has like a fourth of the pizza. So whatever a fourth of the pizza is. So 1 pizza for 4 people. He's going to order us lots of pizza. All right. Anyways, we're going to talk about the lesson. We'll talk about pizza later. All right. So the area of a sector theorem is the ratio of the area of a sector of a circle to the area of the whole circle, which is pi r squared, is equal to the ratio of the measure of the intercepted arc to 360. So the formula for the area of a sector is the arc measure over 360 times pi r squared. Because pi r squared is the area of the whole circle. So you take that arc measure they're given over 360 times the area of the circle. Arc over 360 times pi r squared will tell you the area of a sector of a circle. Because you know a sector is part of a circle, it's not the whole thing. So that's why you use this fraction times the area of the whole circle. All right. Find the area of the sector formed by angle UTB. Here's angle UTB. It's an inscribed angle. It's at the center. So we're looking for the area of the yellow sector. Okay? Find the area of the yellow sector. So we're going to use that formula that's at the top of the screen. Area of a sector equals arc over 360 times pi r squared. Now, if this angle is at the center and it's 70 degrees, its intercepted arc is also 70 degrees, correct? Yes. If we're at the center, it's the same. If we're on the edge, we double it. Right? If it's the center, it's the same. If it's on the edge, we double it. Okay? So that arc measure is 70 degrees. So to find the area, it says both of these sectors, right? So we need a blue area and a yellow area. So we're doing the yellow first, the small one. Okay? So we do its arc measure, which is 70 over 360 times pi r squared. Well, what's the radius of that whole circle? 8 units. Y'all with me? Y'all are going to need a calculator today. So, what is 8 squared? 64. Now, I do not want you using 3.14 times pi for pi. There is a pi button on your calculator. Okay? Because 3.14 is the rounded estimation of pi. So we don't want to use that unless we have to. Okay, we want to keep our areas as exact as possible. Some people don't listen to me when I say stuff. All right. So when I type this in my calculator, y'all understand how I got 64? It told me the radius of that blue circle was 8. So that's how I got 64, 8 squared, radius squared. Okay? So you're going to type parentheses. You want to use parentheses for your fraction. 70 divided by 360, close parentheses. And then you can, I think you can do it without hitting times, but I'm going to hit times just in case. Times 64. Does anybody see the pi before I tell you where it is? It's on the rooftop button, isn't it? And it's kind of diagonal. It's like a yellow color, or it's a whatever color yours is, right? It's a different color. So to hit that, you hit the second button. The second button, remember on our graphic calculators, is like the shift key. So whatever color your second button, you get that colored image. So if you hit second rooftop, that will tell you the pi symbol. So what that does is it keeps a lot of pi in there and not just a rounded approximation of pi. Because we know pi has digits that go forever. Hit enter. And that is approximately 39.1, right? I'm going to use squiggles because we're rounding. 39.1. It didn't have any units, did it? So that's the area of the yellow sector. I did not spell unit. Look at that. Units. And that's the area of the small sector. All right. Now there's two different ways I could get the area of the blue sector, the big sector. Can somebody tell me one way you think? 360 minus 70 to get that arc measure, correct? And then we do the same thing except for this number changes to that number, right? Is there another way we could do it? Absolutely. We could find the area of the whole sector, which is 64 times pi, right? Because that's pi r squared, the area of the whole circle, right? And then subtract the area of the yellow sector. Which one do you think you want to do? Let's do that. So it'll be 64 pi. So area of the big, it'll be area of whole circle minus area of yellow sector will equal the area of the blue sector. So what is 64 times pi? Y'all can just type in straight 64 pi in your calculator. About 201.1 minus, we said 39.1. What do we get? About 162 units. Aren't these going to be square units? Because they're areas. So I need to go back and put square units on my areas. So do y'all see how we got the area of the yellow and then how we got the area of the blue? You absolutely could do the area of this big arc over 360 times 64 pi as well. Okay? And we're rounding, so it might be off by a few decimal places, right? Because when our calculator rounds pi a little bit, not as much as we do when we do 3.14. But we should be close. But that's two ways y'all can do it. Can y'all try this one? Find the area of the whole circle, circle D. Find the area of the yellow sector and the area of the blue sector. Try it. If you need help, ask me or whisper to a neighbor. That looks like my piece of cornbread. Put some white beans on it. Good stuff. You don't like beans and cornbread? That's my favorite meal ever. Beans and cornbread. Slather some butter and molasses on it. Do the rest of it. Y'all need help putting something in your calculator, I can show you the magic buttons if you need to. Let me know. get all your answers, check them with somebody. If y'all are close, like I said, you might have rounded it just slightly differently, so your decimal places might be a little different, and that's okay. Just make sure your numbers are pretty close. Okay. All right, what's the formula for area of a circle, y'all? Area equals what? Pi r squared. And what's the radius of this circle? 14. So it's pi times 14 squared. What's 14 squared? So it's pi times 196, which is approximately what? I got 7.5, so 0.8, 0.75, and y'all, these are not, oh, it has feet, so it's square feet. So make sure your units are all square feet, because you're talking about area, you need units squared. So did y'all get something close to that for the area of the whole circle? Everybody? Everybody? Y'all been finding the area of the circle for a long time. I know you did it in 8th grade. Right? This is part of the 8th grade curriculum. All right. So the area of the yellow sector, that's the small sector. So if that inscribed angle is 120 degrees, what's this arc measure? 120 degrees. So the area of the yellow sector is going to be 120 over 360 times, you can put that number in, or you can just hit pi times 196 in your calculator and keep it a little bit more accurate. So did y'all figure out how to use your fractions on there? Parentheses 120 over 360 times 196 pi. And it don't matter. That's all multiplication, so it doesn't matter the order. I forgot the 6. Did y'all get about 205.25? 205.3-ish? Did y'all get that? Something close? So that's going to be approximately 205.3 square feet, right? And then, so how can you find the blue sector? There's 2 ways you can do it. Yeah, you can say this minus this, can't you? Y'all do that, or did you do it separately and do the blue? Did anybody do it separately and do the blue? Okay, so y'all did 615 minus 205 approximately. What did you get when you subtract those? About 410.5 square feet. You see how I did that? Did y'all get something close to that? Anybody not? So are there any questions? If you have any questions, you need to let me know. Is everybody good with that? Okay. So next we're going to kind of work it backwards. They're going to give us the area of the sector, and we're going to use that to find the area of the circle. So they give us the area of the little sector, or one of the sectors, and we'll use that to find the area of the circle. So remember the formula for area of the sector. Which was the arc length over 360 times pi r squared. Right? That was how we found the area of the sector. Now pi r squared, that part is the what? Pi r squared is what? Area of the circle. So if I know the area of the sector, I can plug that in on the left side and use that to help us find the area of the circle. Y'all see that? Okay. So we're going to call that X. This whole thing right here is the area of the circle, so we're going to call it X. I need a bigger X. So X equals area of the circle, because that's what pi r squared is. Okay? Is everybody with me? So they told me the area of that yellow sector was what? 35 meters squared. Equals, what's the arc measure? Yeah, it's inscribed 40, so the arc measure is also 40 degrees. So 40 over 360, and we're going to multiply that times x, and that's the area of the circle. Because that's what pi r squared is area of the circle. So anytime I'm seeing pi r squared, I'm replacing that with an x, which means, and I set that to be the area of the circle. Because that's what I'm trying to find, the area of the whole circle. I know the area of the yellow piece. I want to find the area of the whole entire circle. That's what I'm finding. All right, so how do I solve this for x? How do I get rid of a fraction times a variable, Algebra 1? Multiply by the, starts with the r, reciprocal. So the reciprocal of 40 over 360 is 360 over 40. So I'm going to multiply by 360 over 40 on both sides. I'm going to put that 35 over 1. Wait a second. Doesn't 40 does go into 360, right? Cancel the zeros. Isn't 36 divided by 4 equal to 9? So this is 9 times 35. So the area of the circle will be whatever 9 times 35 is. (315 square meters). Okay, so if the fraction things confuse you, you got a calculator. You know how to put in that fraction. Parentheses, 360 divided by 40, close parentheses, times 35 will do it for you. Okay, I just prefer to use my brain when I have it. When my brain's working, I prefer to use it. So y'all understand that? So they gave us this little area of this little sector. We used that to find the area of the whole circle. Okay? So we kind of worked that formula backwards. Let's do it again. This is a you try. Y'all think y'all can try, or do y'all want to do it together? Y'all try, and then we'll do it together. So they give you the area of the blue sector. You find the area of the whole circle. And that says 214.37, if you can't read that. The big circle? 360 over 35. But it's talking about centimeters, so it's really not that big. we set this up to start with? Area of the circle, which is 214.37, equals the arc measure, which is what? 85 degrees over 360 degrees times the area of the circle, which is what we're trying to find. Right? So how do I get rid of that fraction? So the reciprocal is 360 over 85. And I'll just be honest, I put that straight in my calculator with that decimal over there. Did y'all get it? What'd y'all get? 907.92. What? Squared centimeters equals the area of the circle. Raise your hand if you got something close to that. Any questions about it? Does anybody have a question about how to find the area of the whole circle? All right, I've got two more examples. Check this out. Three circles, you're right. What is the area of the part that appears blue? Isn't this funny? We're going to use our noggins a little bit. All right. So, how do you think we're finding the area of the blue parts? How do you think we're going to do that? Find the area of the three circles, right? Y'all see if there's three circles? There's the whole circle that circumscribes the two circles. The two circles are up against each other. And what else does it tell me about the little circles? But what did they tell me in the writing? They're congruent. That's an important word, right? Y'all see that? Okay, so those two circles are the same. Can I get the area of all my circles? Well, we know we can the little circles because, right, they told me they're congruent, so they're going to have an equal radii, right? Equal radii. I like saying that word. Radii. So let's just go ahead and find the area of the little circles. Area of little circles. So it's going to be pi times 3 squared, right? So 9 times pi. What is 9 times pi approximately? Put 9 pi in your calculator. Approximately 28.3 square meters. Y'all with me? Is that the area of both little circles or just one little circle? That's one little circle. So for the area of both the little circles is what? Yeah, you double it. 2 times 28.3, which is what? Meters squared. So that's the area of the two white circles. So to get the blue area, I need the area of what? The whole big circle. So if I take the area of the whole big circle and then subtract both of their areas, I can have what's left over in blue. Does that make sense? Does everybody understand that? I take the area of the whole circle, subtract off the two white circles. That will leave me the area of the blue parts. Okay? So, to get the area of the whole big circle, I need a radius. Right? What's the radius of that big circle? What? Right. Because if all the radii is 3, so that means from here to here is 3, right? And so from here to here is 3. Well, these circles are meeting in the center. 3 and 3 is 6. Y'all agree? So the big circle was going to be pi times 6 squared, which is pi times 36. So you can put 36 pi in your calculator. About 113.1 square meter. So how are we going to find the area of the blue part? Yeah. Well, actually, I'm going to do the 56.6 where I doubled it. Right? We got two of them. 113.1 minus 56.6. Approximately 56.5 square meters. Does everybody understand how we got that? So you need to get the area of the outside, the big thing, and then subtract off the parts you don't need. Okay? One more. Check that out. That's really bright. It's not as bright on my screen as on the projector. Bless you. A rectangle wall has an entrance cut into it. It's kind of like an archway door. You want to paint the wall. To the nearest square foot was the area of the region you need to paint. Because you're not going to paint this area because that's an opening. That's where people walk through. Right? That's just air. Yeah, you'll be painting the air. Okay, y'all, paint's expensive. It's like $30 a gallon of paint. You know how many gallons it took for me to paint this classroom? 5.5. Yeah, I didn't. $600. Yeah, exactly. So, you don't want to mess up your math when you're buying paint for your house. Okay? Huh? Yes, I'm going to call her next time I need paint. Okay? How many times does she have to go get more paint? Okay. There you go. He's telling on his mama. Alright? So, but gosh, it looks so good. I'm so jealous. I'm going to go sit in y'all's living room because y'all's house is way prettier than mine. Alright. So, yeah, buying paint, you want to be accurate with your math and how much you need. So this is a real life application. Meaning this is, you would actually, one day, you're going to have a house. And if you're a girl, you're going to get tired of your paint colors and want to change it every 5 years. Mine's been on there for 10. I'm screaming for it to change. And if you're a husband, you're going to have to be the one running and getting and slapping the paint. Or shelling out the money for somebody else to come do it. Right? All right. So, anyways, we want to find how much paint we need to cover this wall. All right. So, I've got my measurements all here. We're not painting the white part. Right? What kind of shapes are going on here? Right. I've got a rectangle right here. Technically, it's a square because I'll just measure up to 16 feet. So it's actually 16 by 16 feet. So it's actually a square. Right? And then a half a circle. Right? So we got to find the area of this rectangle, which is actually a square, and this half a circle, and subtract it from the area of the whole rectangle. So let's go ahead and find the area of the whole wall. Okay? So the entire wall, including the opening, how do you find the area of a rectangle? Length times width. So what's the total length and width? 36 times 26, which is what? 936 what units? Square feet. That's the whole wall. Now we want to subtract off the doorway, which will be this rectangle and this semicircle. So let's first do the rectangle part. So the square. How do you find the area of that? You can do length times width, right? So 16 times 16, which is what? Y'all should know 16 square. 256 square feet. And then we need to find the area of a semicircle. How do you think you find the area of a semicircle? Yeah, you find the area of what the whole circle would be. That's terrible drawing. And then you subtract half of it. Or you divide it by 2. Does that make sense? Find the area of what the whole circle would be and take half of it. Well, that 16 feet across is the what of that circle? Diameter. What do you need for area? So the radius, if the whole diameter is 16 feet, the radius is how many feet? 8, half of it, right? So for the circle, you're going to say pi times 8 squared, which would be 64 times pi. What's 64 times pi? 201.1 square feet. But we don't need the whole circle. We need half of it, right? Right? So we divide that by 2. So for the semicircle, I'm getting 100.5. Yeah, give me 1 decimal. So we can add the rectangle plus the semicircle and subtract from 936 to get the area of the whole arc. Y'all see that? Okay. So let's add 256 plus 100.1. Do what? Oh, 100.5, sorry. Fix that. Exactly. So we're going to say 936, the whole wall, minus the area of the archway is 356.5, which leaves us with a wall space of what? Approximately 579.5 square feet. So, Will, next time your mama wants to paint a wall, you can find out how much she needs for it. Y'all are done, aren't you? I hear you. Well, unless y'all come over and paint your neighbors. I know, it's beautiful. The kitchen looks good too. All right, I'm going to end the lesson right now. Thank you. Have a good day.